So the hope is that there's learning lessons from this that you can apply to be able to make informed decisions about how you leverage additive, and whether you're working with DI Labs, you're doing it yourself, or you're working with others, it has the ability to make a real impact. There's a lot of variability out there in the marketplace when it comes to pricing from service providers. And you've got the low cost, high volume providers, and then you've got those that aren't low cost, but they're providing high degrees of quality. And the question is, what's the difference from one to the other, and what makes it different?
So one difference there is the way that we think about parts and the way that we capture our expectations from the client before a project starts. That ensures that we're aligned with what we need to deliver. As we've experienced outsourcing product, and even clients who've come to us with a failed attempt at additive manufacturing with a product. It's like, these parts aren't meeting our expectations. What we see when those events occur is what we view as little care in the build design process. And the way that parts are oriented and managed in a build has tremendous impact on throughput capability and also quality output. So where a low-cost provider is going to spend less time on build design, they're just packing builds. Our focus is on designing each of those parts to be oriented in the best condition, whether that's a new part we're orienting for the first time, or a legacy part that we are matching past orientations with. We're managing those details today so that quality is key. We want to make sure that each batch, whether it was a year ago or today, is going to match one another, managing the consistency.
What I just heard you say is packing builds for low cost and high throughput versus designing builds for quality and high quality output. That's the distinction that I think you just made, right?
Yeah.
Designing versus packing.
That's right. Yeah, so there's a number of packing tools out there. And those packing tools have some automation built in where you can click a button and the parts get oriented in a way you can control some parameters. But without control of each orientation and management of the orientation of each part, the program, there's not a program out there yet today that's intelligent enough to manage that orientation aspect. And that's where we find a lot of value and improve quality for our clients and manage quality. So we have low scrap, and we're meeting those expectations.
So it's fair to say that for us, the density of our builds is lower than others that are running similar equipment.
In some cases, they might be lower, yeah. They might not be lower. Density doesn't always have the biggest impact on quality. It depends on the types of geometries you have in the build. What's the nominal wall thickness of all the parts? Are you keeping nominal wall parts aligned with other nominal wall parts? And then are you orienting based on the technology to maximize the consistency and prevent the defects?
I see all the numbers floating around here, all the math equations. It's certainly part of the equation. It's a result of designing the builds properly. And there's a lot of aspects of that are critical, but we're producing plastic parts, and in some regards, it's a lot like injection molding. If you run an injection molding process hot and fast, you're going to get different dimensions than if you run it with a different cooling profile. And in our builds, powder bed fusion anyways, works a lot the same way. And so we're packing those builds for the right thermal loading and then cooling those builds with the right cooling rate so that we're not causing dimensional variation. We're able to maintain tight tolerances. And I think we've heard from many that we're able to achieve on some of the HP platform, we're able to achieve tighter tolerances than they intended, than HP intended. And a lot of that's because of the carefulness. We're driven by engineering first, quality first, and throughput and profitability second. And it's really important for us that if we feel like if we can deliver consistently and deliver right on time every time, then that's where we win in the long run. And it's not by pushing as much plastic as we can get through our machines. It's about doing it the right way.
I appreciate your analogy of injection molding, where we're talking about running a tool hot or cold. And let's talk about that potential variability even further. If in injection molding, if you had a part that you designed and you have a tool maker make the tool for you, and they orient that part in the tool in a not optimized condition, maybe the nozzle, the injection nozzle is in the wrong location, or there's not enough injection nozzles. That's a variability that, maybe they're saving money to, make that condition one nozzle, two nozzle in the wrong place. The output is you have a part that's not meeting dimensional requirements. And that is comparable to our build designing process. If we're packing builds, and we're just throwing parts in and it's high density and the orientation isn't controlled, it's the same as having a tool that's running too hot or too cold, or a part that isn't positioned in the tool for mold flow and plastic flow in an optimized state. So there's very similar conditions that we face.
Yeah, that's exactly right. And the benefit that we get with additive manufacturing is that there's a real-time feedback. So we can test those things without having the capital expense of the tooling. And I say that because both with injection molding and additive manufacturing, there are times where you have a part design and you expect it to come out a certain way, and it doesn't because of the, maybe the shrinkage, the cooling and the shrinkage because of the geometry of the part. So that's something that also plays into effect, plays into this tolerance control issue. So in a lot of those cases, we'll do test runs of parts that may have unique geometries and unpredictable cooling rates, and then we can do tests, validate what the final part is, and then do model calibrations to produce the part that's desired. And in some cases, just like with injection molding, not every time does the part that you put into the file come out of the printer exactly as you designed it. There are limitations within the process control on certain geometries that it actually requires calibration of the model. And so that's an area that we focus quite a bit as well.
And now we're blending in this project management into production management. It's like you're talking about, we're onboarding a new product or a new program for a client, and we have a thoughtful process to go from prototype samples through series production or large volume production. And if we don't follow these steps, it's likely that there's going to be a misstep somewhere along the way. We're going to miss expectations. If you come to us with 5,000, 10,000, or 20,000 parts, we're not going to load those in the machine today and start production and send them to you, because it's likely we're missing something. So we with you, we go through a process. With our clients, we go through a process of ensuring that we understand all the requirements, and as we get to the stage of pilot run to do a final approval of that product, that once we go to production, we are 100% aligned on the deliverables and the results.
Yes, so you're talking about this PPAP process that we have in place. It's the mentality of starting slow to go fast.
That's right.
And asking all the right questions, or as many of the right questions as we can early on, to be able to understand the application, understand the expectations, and then to build a process around successful production. For sure, with projects that are transitioning to production scale, but even for prototypes, that's an area that we also ask lots of questions, and sometimes I'm sure it probably feels like we're pushing to go slow, but in the end, we're coming out fast.
That's right.
I believe that that's why we're so well suited to serve critical applications like medical device, like DoD projects, because we are taking such sharp focus on process control, consistency, repeatability, and driving towards quality rather than just sheer volume.
Yeah, and those critical applications could be, medical requirements, medical type of applications. It could be DoD, where we have a high degree of traceability required, a high degree of precision that's required part after part, and it could be extreme high quantity, where a high quantity at a low price might sound good, but the variability could be high. And for us, following our approach, we see high quantity production as a critical opportunity, because we need to be consistent from the start to the end of that production, whether that's a year or 2 years or 3 years. And our approach ensures that we can get started on the right foot and we can deliver successfully time after time.
And it doesn't just happen automatically.
No, it doesn't.
It doesn't happen automatically.
No.
I wish everybody knew that.
For a customer who has a critical project of theirs, something that's important that they need to deliver successfully, any critical project has a timeline. There is no project that is indefinite. And there's always delays in every program, but it's our goal to prevent any delay that we can. Any delay that's manageable, we're going to prevent that delay through process control and ensuring we're following the steps that we've outlined in our new programs and existing programs. So if timeline is important to our clients, then we do our best to ensure that timelines are met.
Yeah, it's definitely the same story. Timeline, and especially for production parts, a lot of the clients that we work with just count incoming receiving processes. So they just count the product. They don't inspect the product because the reliance is on us to do that. So you can imagine buying 1,000 or 5,000 or 10 parts that are going into your assembly line. Those just get counted at the receiving station. Those go to queuing for production. They're on the assembly line and they don't work. So now you're shutting down an assembly line for parts that you've purchased that don't meet spec. So that's why it matters that time can have this cascading impact, especially if all the process controls aren't in place downstream. And oftentimes they're not, because the reliance is on the supplier to provide quality parts. So it can have a massive impact, and unfortunately it can be inconsistent. So in some cases you might find that everything meets spec, in other cases you might find that it doesn't. It's really critical.